Hello 9th graders! For this video, let me guide you to answer Activity 2 entitled The Other 5. In this activity, we are going to find the other 5 trigonometric ratios given one of them. For better understanding of this activity, let's have the following examples. Sine theta is equal to 20 over 29. We know that sine theta is also equal to opposite over hypotenuse. In determining the trigonometric ratios, we need the opposite side, the adjacent side, and the hypotenuse. But in this example, we only have the opposite side and the hypotenuse. So, kailangan muna nating hanapin ang value ng adjacent side. To do this, let's draw a right triangle with reference angle at angle theta. Let's label it using the given values. The opposite side, that is 20, and the hypotenuse, that is 29. The adjacent side is unknown. Let's name the triangle as ABC with right angle at C. The hypotenuse is represented by small c, the opposite side is represented by small a, and the adjacent side is represented by small b. To find the value of b, we will use the Pythagorean theorem using the formula b squared is equal to c squared minus a squared. By substitution, we have b squared is equal to 29 squared minus 20 squared. Simplifying, we have b squared is equal to 841 minus 400. Subtracting 400 from 841, we have b squared is equal to 441. Extracting the square roots of both sides of the equation will give us the value of b, which is 21. We can now say that the adjacent side is 21 units. We are now ready to find the other 5 trigonometric ratios. Let's start with cosine theta. That is equal to adjacent over hypotenuse. The adjacent side of the angle theta is 21 over the hypotenuse of the right triangle is 29. Therefore, cosine theta is 21 over 29. Next, we have tangent theta. That is equal to opposite over adjacent, or that is 20 over 21. Next is cotangent theta. That is equal to adjacent over opposite. The adjacent side measures 21 over the opposite side measures 20. Therefore, cotangent theta is 21 over 20. Next, we have secant theta. That is hypotenuse over adjacent. The hypotenuse is 29 over the adjacent side, that is 21. And we have the cosecant theta. That is equal to hypotenuse over opposite, or that is 29 over 20. How about this example? Cosine theta is equal to 4 over 5. We know that cosine theta is equal to adjacent over hypotenuse. Just like what we did in the previous example, we first draw a right triangle and label it using the values given. The opposite side is unknown, the hypotenuse is 5, and the adjacent side is 4. We name the right triangle as ABC, and its sides be labeled with small a, b, and c. In this case, we are looking for the value of a, or the opposite side. Again, para makuha ang value ng a, we will use the Pythagorean theorem in the form a squared is equal to c squared minus b squared. By substitution, we have a squared is equal to 5 squared minus 4 squared. Simplifying, we will get a squared is equal to 25 minus 16. Subtracting 16 from 25, we will obtain the value of a squared, which is equal to 9. extracting the square root of both sides of the equation will give us the value of a, which is equal to 3. Then we can say that the value of the opposite side is 3. Next, we are now ready to find the other 5 trigonometric ratios, such as we have sine theta, that is opposite over hypotenuse, or that is 3 over 5. Tangent theta is equal to opposite over adjacent, or that is 3 over 4. Cotangent theta is adjacent over opposite, that is 4 over 3. Secant theta is hypotenuse over adjacent, or that is 5 over 4. And cosecant theta is hypotenuse over opposite, and that is 5 over 3. Next example. Tangent theta is equal to 9 over 40. We know that tangent theta is also equal to opposite over adjacent. Next, here, we're going to draw a right triangle and label it according to the given. We have the opposite side of angle theta, which is equal to 9, and the hypotenuse is unknown. Also, the adjacent side is 40. Naming the triangle with A, B, and C, and its sides with a small a, B, and C. We are looking for the value of C, or that is the hypotenuse. So by Pythagorean theorem, we have C squared is equal to A squared plus B squared. By substitution, that is C squared is equal to 9 squared plus 40 squared. C squared is equal to 81 plus 1,600. C squared now is equal to 1,681. Extracting the square root of both sides of the equation, we will obtain the value of C, which is 41. Therefore, we can say that the hypotenuse measures 41 units. Now we're ready to establish the other 5 trigonometric ratios, starting with sine theta, that is equal to opposite over hypotenuse, that is equivalent to 9 over 41. Cosine theta is equal to adjacent over hypotenuse, or that is 40 over 41. Cotangent theta is equal to adjacent over opposite, that is 40 over 9. Secant theta is equal to hypotenuse over adjacent, or that is 41 over 40. And cosecant theta is hypotenuse over opposite, or that is 41 over 9. Tayo ay nasa huling bahagi na ng ating talakayan para sa linggong ito. For this video, let me guide you to answer Activity 3 entitled Illustration. In this activity, we are going to illustrate a triangle based on a given trigonometric ratios and the reference angle. Upang higit ninyo itong maunawaan, let's have the following examples. Illustrate right triangle LOT given the acute angle T and the following trigonometric ratios. We have sine T is equal to G over Y and cosine T is equal to M over Y. We know that sine T is also equal to opposite over hypotenuse. And we also know that cosine T is equal to adjacent over hypotenuse. Now, let's draw a right triangle and label it as LOT. Based on the instruction, our reference angle is angle T. With respect to this angle, side LO is the opposite side. Side LT is the hypotenuse, and side OT is the adjacent side. Now, we will substitute the name of the sides according to the given trigonometric ratios. The opposite side is G, the adjacent side is M, and the hypotenuse is Y. Now, This is what we are looking for. The illustration of the right triangle with reference angle at angle T and given sine T is equal to G over Y and cosine T is equal to M over Y. As easy as that. Next example. How about if the given is cotangent T is equal to X over Y and cosecant T is equal to Z over Y? Just like what we did in the previous example, we know that cotangent T is also equal to adjacent over opposite, and cosecant is also equal to hypotenuse over opposite. Now, let's draw a right triangle and label it as LOT. Our reference angle is angle T. Now, LO is the opposite side of angle T. LT is the hypotenuse and OT is the adjacent side with respect to angle T. By substitution, the opposite side is Y. The adjacent side is X and the hypotenuse is Z. Therefore, we can say that this is the illustration of the given problem. That's all for this video. Thank you for watching and stay tuned for the next virtual instruction.